Begin, yes, this is the extra practice for 8.5. Even though I put 8.4 on here, it's really 8.5. I got 8.4 happy. And basically what we're doing here is we're adding and subtracting these rational expressions. We're adding and subtracting them. So we're basically doing algebra fractions, adding and subtracting algebra fractions. And to add and subtract fractions, you must always, always, always have the same size pieces. So if you have 1/3 plus 1/2, you can't add those together because they're different size pieces. A half of a pizza is different from a third of a pizza. So you have to multiply this one by 2 and multiply this one by 2 and then multiply this by 3 and multiply this by 3 to create a common denominator. So we have 2, 6, which is 1/3, plus 3, 6, which is 5, 6. So that's the concept here, is you have to make the denominators the same in order to add and subtract. So that's what we're going to be doing the whole way through, and we're going to be doing that by factoring. So here we begin. So I start off some easy ones, work our way into some more complicated ones, and a pause here for a second. And I'm back. So we need to make these the same. So we're looking at this and we're like, this has an X and this has an X, this has a Y, and oh, this one doesn't, got to have a Y. So we're going to multiply the denominator by Y. But what you do to the bottom of the fraction, you must do to the top. What you do to the denominator, you got to do to the numerator as far as multiplication. Now you can't change a fraction by adding numbers to the numerator and denominator, or subtracting numbers from the numerator and denominator, but you can definitely change a fraction and keep it in the same proportion by multiplying the denominator and the numerator by the same amount. So that's legal, okay? But subtracting, like over here, I couldn't like subtract 1 and subtract 1 and call that 4/5, because 4/5 is not 5/6. That would not be correct. But you can multiply by 2 and multiply by 2 and make it 10 over 12. I wrote 16. Why did I write 16? 12. So 10 over 12 is perfectly legal. All right, back to this. So now I have a common denominator, and I can just go ahead and add these together. So I got 8y plus 6. And you can't really add those together, so you just write 8y plus 6, or 6 plus 8y over the common denominator, and that's the answer. So again, the restrictions come from setting the bottom equal to 0, the denominator equal to 0, and just x can't be 0, and y cannot be 0. So either one of those would be bad. All right, going on to the next one. We need a common denominator here, so y and y, x squared. That's 2 x's multiplied together. Oops, we're missing an x over here, so we're going to multiply by x. Now with subtraction, you can't switch the order of it unless you pay the price of a negative sign, so this is just 2 minus x. So I write 2 minus x over x squared y. That's the common denominator. And again, x and y cannot be 0. X cannot be 0, and y cannot be 0. Ba-boom. Okay, now we're moving on to the next one here, which is getting a common denominator. So this denominator here has an x plus 2, and this, or x plus 1, and this denominator here doesn't have anything except for an invisible 1. So I just need to multiply the bottom of that fraction by x plus 1, and then do the same thing to the top over here. So x plus 1 over x plus 1 cancels out, and you're left with 2. So that's the whole deal from like the last section and all that good stuff. All right, so now I can distribute this through the parentheses. So I get 1 plus 2x plus 2 over the common denominator, x plus 1. Then I can add those two together, so I get 2x plus 1, 2x plus 3, my bad, over x plus 1. And then you can't divide by 0, so going back up here, it's just x cannot be negative 1. And that's the only issue right there. Pause here for a second, and I'm back. So the next one here, we're going to do what I call an inventory. We're going to see what we have and then place an order for what we need. By inventory, I mean factoring, because we need to know the parts and the pieces that we have. So we have 6 over parentheses, 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 minus 5 over x plus 2. This does not factor. So I can factor this into x plus 2 and x plus 2. So this has double x plus 2. This only has 1. So I need to multiply by another x plus 2. You know what? I'm going to get, here's my green pen. I'll use that. X plus 2 and x plus 2. There we go. So I don't know if you can tell that's green or not. Yeah, I think you can. So now they're the same. The restriction, of course, is just x cannot be negative 2, because that would cause division of 0 all the way across. Now, the subtraction ones, you have to be tricky, because you have to distribute the negative 5. Not just the 5, it's because it's really negative 5. So if you want to, you can make this add the opposite and think about distributing negative 5 through the parentheses. So it is 6 negative 5x minus 10 over, I'm going to go ahead and write this as x plus 2 quantity squared. I think that's okay to do. Then we can put the 10 and the 6 together. You borrow 10 from the old aunt and you pay her back 6 because that's positive. You still owe 4. So the final answer is negative 5x minus 4 over x plus 2 quantity squared. And typically the way we want to leave these in calculus class is we simplify when we're doing these problems that involve these fractions in calculus. This was kind of designed for Algebra 2, but we usually leave this factored and we simplify the top of the fraction. So we simplify the numerator and leave the denominator factored. That's kind of the rule of thumb that I follow. Okay. Now, I think I just knocked the camera. Whoa. And refocus. Perfect. All right. Neither one of these have any common factor in there, and they're factored. So each one of them needs the other one. It's kind of like I did this example here. The 3 and 2 have nothing to do with each other, so this one needs the 2 and the other one needs the 3 to make it a common denominator. So we're going to multiply by the opposite thing here that it doesn't have. So x minus 3. So this one has an x plus 3, and this one has an x minus 3. This one has an x minus 5. Now this one needs an x minus 5. And if you put it on the bottom of the fraction, you need to put it on the top of the fraction. Ba-boom, like that. Now we got some distributing to do. Distribute, 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 distribute. If you put 3 or 5, then here that would definitely be bad to divide by the 0. So the restrictions are x cannot be 5 or 3. All right, now let's do the problem. Distributing 4x minus 20 plus 9x minus 27 over the common denominator x minus 5, x minus 3. The x's go together, making 13. You borrow 20 from the aunt and 27 from the uncle, so you owe them 47. And that's how that one goes. All right. The next one, I'm going to do an inventory, so I will factor to see what I have, and then I can place an order for what I need. So it's 5, and it also helps you with the restrictions to see what x cannot be. And 2 sets of parentheses, x and x, and 6 and 2, yeah, because 3 and 4 wouldn't make the 4 in the middle, so it's 6, then 6 needs to be negative, the 2 needs to be positive. Then I can see what the other one doesn't have a lot easier. So this one has an x minus 6, and this one has an x minus 6. This one has an x plus 2, and this one doesn't, so I need to multiply by x plus 2. Okay, now they're almost exactly the same, except for this one needs a 2 over here, so I'll multiply by 2. Do it on the top and the bottom. Okay, distributing. So I get 5x plus 10 minus 40 over the common denominator, which is 2 times x plus 2, x minus 6. The 40 and the 10 can go together, so it's 5x minus 30 over 2 times x plus 2, x minus 6. And then I have the restriction situation. So x cannot be what? Negative 2 and 6. negative 2, and 6 would be the two restrictions there. So that's the situation with this one here. I factored, and then I could see what I needed to make the denominators be the same. Ooh, here's a cool trick on this one here. You can switch the order of subtraction. You can totally switch the order of subtraction, but you have to pay the price of a negative sign. So you can see that these are just switched of each other. So if I switch the order here, guess what it's going to do to that sign? It's going to switch it. So it's 2 minus 5x over x minus 9 minus 4x minus 5 over x minus 9. So now I have a common denominator by switching the order of subtraction, but I paid the price by multiplying by negative 1, which now makes that a positive there. We do have to distribute this negative through the parentheses. So I have 2 minus 5x minus 4x, because I'm doing negative times that. Now negative times that would be plus 5 over x minus 9. Then I put my numbers together. That would be 7. And then if you borrow and borrow, you have minus 9 over x minus 9. And that's the answer. And then, of course, you can't have 9 there because that would cause a division of 0. So x cannot be 9. All right, now the last one. So the same thing again here. We're going to do a lot of factoring to inventory to see what I have. We have x and x and x and x. And we have 2 and x, 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 x. There we go. I factored that earlier. And then this would be, what, 2 and 3? So that's how that factors. And you're like, hey, this one has an x plus 3, and this one over here needs the x plus 3. So I need to multiply. I've kind of run out of room here, right? So I'm going to multiply by x plus 3. And if I have to do that on the top. And then this one has 2x plus 2, so this needs an additional x plus 2. Because it has to match exactly. It has to be common, right? It has to be a common denominator, or it's the least common multiple in the words of the world of math. So I can go ahead and start distributing here. So distribute, 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 distribute. Make sure you distribute negative 2. So I'm going to change this to add negative 2 to distribute the negative 2 through the parentheses. Okay, so now going on, so we get x squared plus 2x. Negative 2 that, negative 2x minus 6. Oh, those are going to cancel out. That's cool. I'm going to write that down as x plus 2 squared because it's 2 of them. And then x plus 3. The x's cancel out, so I'm left with x squared minus 6 over x plus 2 squared, and then x plus 3. That's the final answer. And then negative 2 would be bad because negative 2 plus 2 would be 0, and of course negative 3. So x cannot be negative 2 or negative 3. Oh, and I didn't do that in orange. Oh well, it's the only one I didn't do in orange. All right, so there's the extra practice for this one here. Basically, you have to make the denominators be the same. So like in the very first one, I went ahead and multiplied by y. So see, they're exactly the same, and then you can go ahead and add the numerators together once the denominators are exactly the same. So you have to have a common denominator, which is the least common multiple in the world of math.